We're going to talk about the capabilities that you're going to need to be able to self-serve either a data engineering team or a data science team. So what kind of things do you need to be able to do that? I think everybody talks about having, lots of compute power and lots of different compute engines to do these things. But then what about movement of data, right? If you want to manipulate data, you need to be able to easily move it onto that platform. You need a wide variety of processing engines and tools that are available, because that's a really broad range of tasks that you need to achieve, and no one tool or engine is going to support all of that. And then there's a big difference between experimentation and production, and you want a single platform which can do both your experimentation and your production environments. And of course, you want it to be constantly monitored, because I'm pretty sure that none of you all want a pager that rings at midnight to tell you that the environment's down. So you want this to be monitored and managed and upgraded whenever necessary. And I think most companies are pretty sensitive about their data, about privacy. So you also want all of this to be extremely secure and compliant with industry regulatory standards. So if we had to look at what would a platform like that look like, Kazin is an example of a platform that enables this. So all of this is running in a public cloud, but we turn public cloud into private cloud. Right? So even though it's running on either AWS or Azure, there are no publicly accessible points to the service. So the easy bits are multiple engines, right? There's the entire Hadoop and Spark stack that's built in. There's MPP engines that are built in as well. But if it's a private service, how do I get access to it, right? And so the key bit is this Kazina gateway, and you can think of the gateway as a key that unlocks the service, right? So it's a very thin software device, and what it does is it unlocks the service, and it makes all of these cloud services look like they're local to your local machine, right? So everything that I'm doing is going to look like it's local to my machine, even though none of it's actually on my machine, right? So once I have the service up and running, let's talk about data movement. Data that's in the cloud already, that's easy to process in the cloud. It's already in the cloud. But there's lots of organizations that have a ton of data on premise. So how do I deal with the on-premise? How do I deal with the on-premise data? Right. So because I can deploy these gateways anywhere, what that means is that I could have an on-premise system. And so this example has an on-premise database that's sitting behind a firewall, so it's got no publicly accessible endpoints. And as a data scientist or a data engineer, I can just reach directly into that and pull data out of it to start processing. So let's just give it a name. And you can see it's just immediately giving me an inventory of what's available in that on-premise system. So I'm reaching into an on-premise system, looking at what data is available there, and I'm going to just grab one of these and I'm going to move that into a cloud service, right? And that entire thing happens seamlessly. And what it's doing through this process, because I'm moving it to a Hadoop stack, it's automatically creating all of the HDFS directories that are necessary. It's setting up all the Hive meta stores. It's doing all of the security. All of that data that's moving across is being encrypted automatically. That's not an option that you can turn on or off. So everything gets encrypted and then shuffled up into the cloud. And then once it's in the cloud, there's a whole range of services that I can now use that are just built into that service, right? So if I'm a data engineer, I might want to manipulate that data and turn it into something that's more analytic ready. So in this case, I'm gonna just put in a simple piece of Python that's going to leverage one of the Spark engines under the covers, right? So I'm still a Python developer. I can now leverage Spark, but I didn't have to set it up. I didn't have to configure it. I didn't have to figure out how to plug all of my Python libraries into to leverage the Spark. And that's just one of the many languages that could be used. You could be using Python, you could be using Scala, you could use whatever you want within this. But we also find that a lot of people want to start doing statistical analysis. R is a really common language to do statistical analysis. So again, the RStudio IDE is just baked into the servers, right? You just go to a link within it. You get up and running, and once again, all of the plumbing is done for you. So as an R user, I don't have to figure out, now I have RStudio, how do I link my R environment into this data that was just moved in by somebody else, right? Because it's a centralized environment, all of the data that was moved there by the data engineer is now immediately available to the data scientist. I also don't have to figure out how do I get my Spark, my R environment to interact with Spark, and all of the authentication and the security that surrounds all of this. That's all done. That's all done for you, so that you can just go ahead and immediately start to do your analysis. So just to give a simple example there, right? So I can now run a query that's actually going to go and grab that data that I moved out into the cloud through R, and I've got it all locally now to do my regular R processing, right? So this expands my R usage because I now have all of the capabilities that I can normally use in R, but I've also got a Spark cluster for the certain kinds of workloads that Spark can augment, machine learning, if I want to do machine learning, linear regressions, where some of the Spark capabilities and allow me to do some more interesting things. So both those tools that I mentioned are just built into the servers, right? There's nothing that you have to do there. However, we all know that everybody has their own tool of choice, right? So what happens if I'm using a tool that Kazina doesn't bake into its service? So again, the gateway is the key there, that you can take any existing tool. So I'm going to take a tool that's installed on my laptop. So let's choose Tableau, right? And I'm going to point it to that gateway. And what that's going to do is it's going to allow the tool now to securely interact with the service, right? So the tool's living on my laptop, the service is out in the cloud. Because I point to the gateway is going to ensure that all of the communication between my laptop and that cloud service is now authenticated and secure. Right. So as an end user, I don't actually realize that I'm running on a cloud environment, right? All of those cloud services just looks local, local to where I reside. Right, and so I can just be a Tableau user, I connect to the service. I don't have to know that you have to connect securely to the cloud. I don't have to know that I need to encrypt all of the data. I don't have to know any of those things. I just work with it as a regular service. And so I've got all of those things that are running. I've got lots of engines. Who's monitoring and maintaining all of this, right? So that's a key part of the service, right? Is that the service is continually monitored and managed by software and a team of people to ensure that that platform stays up and running all the time, right? So you have a fully managed platform that is going to upgrade as new releases come in. It's going to make sure that all of your security patches are up to date. All of the monitoring and maintenance and the grunge work gets done behind the scenes, so that you can focus on loading data, transforming data, analyzing data. Right? And that's it. If there's any questions.